All right, so review packet 3 and 4 are both starting in with triangles. And one of the biggest things that they're hitting with triangles is they're doing all congruence and then all similarity all at the same time. So that's kind of the reason why I want to make sure we do them both together. Plus, they changed everything on me. So if AC equals BC, that means these two sides right here are congruent, right? If those two sides are congruent, that makes this an isosceles triangle. And if it's an isosceles triangle, it means 8x minus 40 equals 5x minus 1. All right.
Are we going to do number 1?
No, I wasn't going to do number 1, but I'll set it up for you here in a second, okay?
Okay, thank you.
Yep. All right, so if these two angles down here are congruent, then I can solve for x. So I've got this bad boy moving over. So I've got 3x minus 40 equals negative 1. And that makes x equals 13. So now you got to take 13 and you got to plug it back in. All right, so 5 times 13 minus 1. Calculator, where did you go? There you are. So 5 times 13 minus 1. That gives me 64. All right. So that means angle A and angle B are both 64 degrees. All right. Now I know that for every triangle, all of the angles combined is 180. So I need to do 180 minus both of these 64s. So I can find angle C. And I get 52. All right, so that is actually my final answer for this one. All right, so Maggie, you asked me to set up the first one. For the first one, we know all of those angles have to add up to being 180 still, right? So I've got 8x plus 3 plus 3x plus 16 plus 10x minus 28. And that all equals 180. All right, cool. If I scroll down here to number 3, this is the exterior angle, like converse of triangle, blah, 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 blah. Anyway, basically what it says is this outside one equals these two added together. All right, so 16x minus 7 equals 8x plus 2 plus 10x minus 19. Okay. So
I love when you do the thumbs up.
yeah, thumbs up just makes life easier. It honestly, like doing that even in class just makes life. All right, so for topic 2, the one thing I do kind of want to go over with it first is Pythagorean theorem. All right, so all right, I've got a squared plus b squared. And then I'm going to put a little line right here with a question mark and c squared. All right, so if they are equal, then it's a right triangle. If AB are greater than c squared, then it's going to be acute. And if it goes the opposite way, it is obtuse. Okay.
Is that important? Should we write that down?
I would write that down because that's what you're going to need for all of topic 2.
Okay, hold on a minute.
Right, I hold.
Dad, can you hand me that yellow thing, please? Yes, please.
So let's just kind of do some of the evens. All right, so it says which of the sides could possibly be a triangle. All right, so when you're looking at just plain old side lengths, you need A plus B to be greater than C for it to even form a triangle. Okay?
Question.
Yes.
Is it, okay, so is there like an easier way to not have to like solve, or like to not have to solve for like all of them? Is there like a special way that you can like find out if it's a right triangle just by looking at the numbers? Or like
No.
No.
Not unless you have all the Pythagorean triples memorized. Sorry.
Oh,
I wish
no,
there was
don't
a
have that
nice way.
memorized.
Yeah, don't have them memorized. It's not worth it. Okay, so 8 plus 8 is 16. That's not bigger than this. So this is not going to form a triangle. All right, 2 plus 11, that gives me 13. That is bigger than 12, so this one's good. 6 plus 15, that's 21. That is bigger than 20. This one's good. And then 19 and 15 add together to equal 34. 34 equaling 34. Not bigger than, so that's out. So these two will actually form a triangle. Okay.
Okay, so I don't think my question made sense.
So there's two different things that are happening here. So you've got, will it make a triangle, yes or no? And then if it does, what kind of triangle? So what I gave you first is what kind of triangle will it create? Does that make sense? That's why it's squared.
Right, so, but how do you know what A and B? Whoa, where'd it go? Oh wait, it's right here. How do you know like A and B? So that was like C 11 and 2.
Mm-hmm. So C is always going to be your biggest side. All right, A and B, the order of those don't matter.
Okay, hold on. But you said A and B don't matter?
Doesn't matter which order they go in.
Okay.
All right. So,
thank you.
You're welcome. So if I go kind of back up here, all right, some of the other questions they're going to ask you for is what are the ranges of sides that this could create? Okay, so for number 6, it says two sides of a triangle measure 24 and 29 inches. Which of the following sides could represent a third side? Okay, so what you do to find that third side, so C has to be somewhere between, and it is 29 minus 24, and then 29 plus 24. All right, so C has to be anything between 5 and 53. So what are the only two numbers that are between 5 and 53? 7 and 31.
7 and 31.
Yep. All right. And then number 8. Oh, sorry, Maggie. All right, so this final one, number 8, says write the order of the angles from least to greatest. So when you have a triangle, all right, anytime you have a triangle, the bigger the side, the bigger the angle. Hang on. All right, so DE is 18, EF is 5, and DF is 19. So the biggest angle is directly across from the 19, and that's going to be right here. All right, so that would be angle DEF and that's going to be the biggest. And then I will have angle DFE, and that'll be my middle one. And then my smallest one is going to be angle EDF.
So with that DEF, is that is that 19?
Yeah, so DEF is directly across from the 19.
Okay.
Taylor said that equals 90, that DEF is?
She didn't say it's
No,
90. She just asked if it was directly across from the 19. And that's where I got it from.
Sorry.
No, that's good.
I thought I heard 90. My bad.
All right. Can we flip over to the next page? All right. So on the next page, all right, it's going to start asking us for these values. So they tell you that PQR is congruent to WXY. All right, so remember, the order of this matters. So PQ is the same as WX. All right, so here's PQ, here's WX. So if WX is 7.7, PQ also needs to be 7.7. All right, QR is the last two, and that should match with XY. So if QR is 17, then this one over here also needs to equal 17. And then obviously last side is 15.4. All right, and then when it comes to angles,
can you fill in the letters?
Yeah, I'll fill them in here just 1 second. I want to finish the angles, okay? All right, so 27 is obviously right here. This one's missing a 65, and this one's missing an 88. All right, so once I fill everything in on the picture, then I go over and fill in the bubbles, because now it's real easy. I can go, okay, PQ is 7.7, WY is 15.4, and I got 17. This is 27 degrees. All right, so for this part, we've got 5 different ways to prove two triangles congruent. You've got side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. This one works for right triangles only. All right. Now, luckily, there are only so many ways to actually come up with when you're doing the proofs. All right. So the reasoning on the proofs is going to be one of these 8 things. It's either going to be given, definition of a midpoint, and the reflexive property. And then for angles, it's going to be given, vertical angles, corresponding angles. I'm just going to keep writing, okay, Maggie, and then I'll pause it for a second so you can copy.
Okay.
And then I've got angle bisector. So when it comes to these examples, all you're looking for is which of the 5 methods can you use to prove it, and then writing the congruency statements. All right, so when I look at these, the first thing I look for is always vertical angles or reflexive properties that I can mark, because that means I've got another piece of information. And it's one of the only ones that you can actually get off of the picture without being given it. So for this one, I now have angle, side, red angle, black angle, side, red angle. So these are proven congruent with side angle, or angle, side angle, my bad. And then the actual congruency statements are triangle A, B, C is congruent to triangle E, D, C.
How do you find that out? Like, how do you know that?
So
angle, side angle.
So I've got an angle, right? I've got a side. The only other angle I can possibly fill in is the ones that come from vertical angles. Okay.
Okay.
So
can you do 13? Because like that's with like 3 little key things.
Okay, what do those little things mean? What are the little markings?
I know
mean?
one means, aren't those like parallel? Like one means parallel, right?
One means congruent. The 2s mean these 2 match up, and the 3s mean these 2 match up. They just use multiple lines to designate which ones match with which. Okay. So like one line here is congruent to one line over here, and then 2 lines and 2 lines, and then 3 lines and 3 lines. All right. So you have.
Okay. Hold on a minute.
Oh.
Sorry.
No, you're good.
And 3 lines. Is that your husband on the phone?
Yeah.
Okay. Keep
all
going.
Right. So now I have all 3 sides with matching pairs. So I can say that they are congruent with side angle side, and then I just need to match up for my congruency statement. So if I start at S here and I go RT, all right, I started at S and then I went purple, blue, red. So I need to start at W for this one, and I need to go purple, blue, red. So it'll go W, Y, and X.
Because, so when you went SRT, do you like have to start with like the 3 tick marks, or can you start anywhere?
You
like,
can start anywhere.
Could you do RTS or TRS or STR? I mean,
yeah, any of those work. You just want corresponding parts on the 2 triangles to go in the same order, because the way this is written is I'm telling you angle S is congruent to angle W, right? Because those both come first. Yeah. And then SR is congruent to WY and so on and so forth.
Okay.
Okie dokie.
Okay. Yep.
All right. Yep. So on the next page, all right, let's do 14. So for 14, I've got a pair of sides, right? 3 and 3. And then I've got these 2 angles down here. And then when you have parallel lines, remember that these arrows mean parallel.
Yeah.
that's typically when you're going to start using consecutive or alternate interior angles. Or not consecutive, I'm sorry, corresponding. All right, so I'm going to say this angle right here in purple and this angle up here by H both match because those are corresponding angles. All right,
Okay.
so I have enough to say angle, angle, side as being my congruence. And then it's your congruency statement again. Do you want help writing the congruency statement? Yeah, okay.
Yeah.
So if I start with J and then I go to H and then I go to G, what order would I have to go in for the other triangle?
Sweet. If you did J, H, G, you'd have to wait. So J, G, do you have to do K, H, I?
K-I-H. All right, so notice I went purple or blue to purple, right? And
okay. You didn't. Okay, you can't go. So you went up over.
Yeah,
Not
I went up and then to
over
your
the other
left.
way.
Mm-hmm.
Okay.
So whatever way you go on the first one, you have to follow that same order on that second triangle.
Or will it not be?
Then
Like,
they won't
could
be
it, like-
congruent.
Oh, okay. Okay.
And I'm going to leave 16 just because I did 3 on the other page.
Ugh.
I know. I did 13. So now you got
Okay.
3 on
I'm
your
okay
own.
with that.
All right. You guys ready to do some proofs?
No, but let's go for it.
All right. So first step is always given. All right. That's always easy. Now, luckily, all of your options for things you can write in come from the list we wrote on the other page. Okay. So I've got QS, this segment right here, bisecting PSR. So if it bisects, it means these two angles here are congruent. All right. So if you flip back a page and you look at that list you wrote, how can I say these two angles are congruent?
Wait. Side, side, side?
Nope. Look down and look under the box on the right that says list reasons why angles can be congruent. So was this part given?
It bisects.
Yep, it bisects. Kennedy, I think you said that. It's an angle bisector. All right. So for this one, anytime you see QS is congruent to QS, that's reflexive. All right, and that's right here. And then they give me that angle QPS right here is congruent to QRS right here. So do I have 3 pieces where I could say these triangles are congruent?
Wait a minute. Hold on.
No worries.
I've got to draw your pictures too. Your fun stuff that you do. I've got to
My
draw
little
it on mine.
notation on my pictures.
Yes, I've got to draw that on mine too. So it's perfect. It matches. We're good. Okay, keep going.
Right. So I have a blue angle, I have purple angles, and I have a side. So I've got angle, angle, side. That's my reason why these are congruent.
Okay, will we be ever using CP something?
CPCTC.
That thing, yes.
I think it might come up in another packet. I
Oh,
think
okay.
it might come up in 4. I'll have to double check.
Is that what's the difference between like that stuff and then like angle side and that type of
So
stuff? Like,
CPCTC is always the step that comes after you prove that triangles are congruent. So once you prove that these triangles are congruent, CPCTC stands for corresponding parts of congruent triangles are congruent. CPCTC.
okay.
So what it says
Right.
is once you've proven that those triangles are congruent, then you can say individual chunks of those triangles are the same. So now that I've got these two being congruent, I can say that PS right here, this segment, is going to be the same as SR.
Do you have to write this down or no?
No, this is just me explaining
Okay.
stuff. Okay.
Okay.
So
So you could do CPT something
Yeah.
something on that.
I could if I needed another step after this.
Okay.
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 But we don't need it
Cool,
on
cool.
any of these proofs.
Okay.
All right. How mad would you be if I made you do 19 on your own?
Very mad.
Very mad. Kennedy's
Yes.
looking at me like, yeah, I'll fight you. Okay, so first one's always easy, right? It's given. All right, and it tells me that E is the midpoint of CG. So how could I say that CE is congruent to EG?
How is it congruent?
Yeah, how are those?
Is it vertical?
That's not for sides. So
Or these angles?
these are segments. So these are side lengths.
Oh.
So you're looking at that left box.
Definition of midpoint.
Yep.
Bam. Got it.
It's all
I feel
about
very proud of
eliminating
myself.
choices that you know obviously don't fit. But if I tell you midpoint, you probably need to use that on the next line. All right, so it says CE and EG are congruent, and then DE and EF are also going to be congruent. All right.
Hold on.
No, you're good.
Wait. Okay, keep going.
Okay, so the last part, remember this one looks like that bow tie pasta? So I can say that these two angles right here are congruent. All right, and
What the
that's,
heck is both?
yep. So why are those angles congruent?
Because they make a 90-degree angle?
No, I don't know that they make 90. You said it earlier, it started with a V.
Vertical.
They are vertical angles.
Oh, you changed colors. I'm changing colors.
All right, so my last step is why are these two triangles congruent? So Kennedy, what do you think?
I think it's side angle side.
I think you are correct. Got a side, got an angle in the middle, got a side right there. Kennedy's looking at me like, wait, I just got that right? Okay. I got a proof right.
What's the first? Nothing.
Mom, I'm doing homework. Leave me alone.
No, we're just congratulating Kennedy that she got this proof right.
My mom's out there like, what?
All right, next page. Got two more proofs. All right.
She's gonna do them with us. Whoop whoop.
Yep.
And half of them got.
Are we gonna have those like really long proofs on like the exam, like with like? Oh, okay.
Your exam is fully multiple choice. So,
Oh, it is.
Yeah.
Oh,
dude,
thank
how am
the
I going
Lord.
to give you anything other than multiple choice? It's not like I'm driving around to 140 kids' houses to pick up like their scratch work for stuff. Like, not happening.
They said that you could do like projects or something. You could give us. Oh wait, I don't want another
Yeah,
project.
you guys already
I'm
did
okay.
projects. We're good.
I'm okay with
We'll
that.
just be done.
No.
All right. So we got the given
Okay.
part, right? So I know that these two are parallel, and then I know these two are parallel.
Hold on,
No, you're good.
Mason. You're great. I freaking love you.
Well, thanks.
You're welcome. wait. I forgot what color I'm choosing. Hold on. Oh, okay, wait. I'll just go with this color. So that's how it works. Here we go.
All right. So now that
Okay,
I've got
you're
my
good.
given written in, all right, they're asking, why can I say that these angles here in green are congruent, and why are these angles in purple congruent?
New color. Oh, here we go. This one work. Oh, I can't see that color. I'm not using that. Let's go back to this one. Wait. Wait. What? Wait. What?
All right, so, oh, okay, maybe I can't do it that way. I was going to zoom
Oh,
in.
don't erase. I already don't erase.
I'm
New
not.
color.
I'm not erasing. I'm not erasing. Calm down.
Okay.
Slow your roll.
I was about to say.
I was trying to
can't
zoom it
change
in.
color.
And even though my computer's a touchscreen, Smart Notebook won't let me 2-finger zoom like I normally do. All right, so if you look here, I've got green and green, one on the top, one on the bottom, and then I've got purple top and bottom. So what is the relationship between the green angles and the purple angles? You have your list of 5, right, for angles.
Wait, where did it go? Hold on. Alternate interior.
Perfect.
I just guessed on that one. So,
But
woohoo,
I
yay
mean,
me.
think about it this way. It makes sense, right? They're not on the same side of the transversal. They're on opposite sides. And they're both on the inside of the parallelogram. So yeah, alternate interior angles.
Woohoo! Shh. Don't bark. Sorry.
No, you're good. All right. So what's the reasoning where I can say AC is congruent to AC?
Reflexive.
Yep, reflexive property. Hang on, I don't know
It's
why.
the same.
Yeah, because they're the
It's
exact
the same thing.
Uh-huh.
Are you doing more to your slime? Huh? Are you doing more to your slime? Your slime? Look at your slime. It's right.
All right, so last step. I've got angles, green angles, pink side, purple angles. All right, so why can I say that those are congruent? Kennedy, it's up to you.
I want to say angle side or angle side angle.
It is angle side angle, and it's angle side angle because the side is in between your 2 angles. Okay.
Wait a minute. Huh.
You're
Hold
good.
on. Oh, you changed colors. Hold on.
I hit the pink button.
I'm changing it to pink also. I'm changing colors.
Thing. I'm totally gonna drive me insane.
Okay.
Thank you.
All right, so last proof. All right, I've got KL is congruent to MN. And then I've got KM, so this entire side here. I'm gonna have to do this. This whole side is congruent to this whole side. Okay, and that straight comes from the givens.
Good.
Yeah, I'm good. Wait, hold on a minute.
Okay.
Did I do that right? M to K and L. Okay.
All right.
Ah!
Hang on.
Okay, we're good.
All right.
So, no, I messed up on my line, but we're good.
Oh, that's okay.
Yeah.
So LM is congruent to LM, and we said that's our easy one. That's reflexive property.
Not you.
I figured it wasn't me, but I might mute you, so we don't get the dog barking on the recording. All right. And then the last step is going to be side, 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 simply because
Why
all
is that
you've
in
been
bold?
given, I don't know why it's bold. I hit a button. It's
Okay.
weird. Whatever. All right. I've got a pair of sides here. I've got a pair of sides here. And then I just found the third side right here. So it's side, side, side.
Okay, hold on a minute.
All right. So this last one, yeah, like I said, I'm not doing it. I would recommend like actually graphing the points and figuring out where things need to be. Distance formula is probably going to be your friend on this one.
Well, there's 3 for the like ABC, and then there's 2. Like so.
So what you would do is you'd graph them first, and based on that, you
Okay.
can figure out where that third point needs to be to make your pictures the same.
Okay.
All right.
I'll get there.
All right. You want to knock out packet 4?
Yes, please.
Okay. So flip it a page.
I'm kind of excited for this because I'm really good at dealing with the Pythagorean theorem, so I think it'll work. I think
Yeah,
we'll be pretty
I think
good
that'll be
with
good
that.
too. All right. All right. So for these, you still have your similarity statements. The similarity statements work in the same way as congruent statements, but they tell you parts that match up. So DF right here, so first and last, that's this chunk right here, matches up with GF, and that's going to be this little chunk right here. So when you go to set these up, I'm going to say, all right, well, 9x minus 13 over 15 equals, and then I'm going to go over here and I'm going to look at EF, so big chunk over the little chunk. So it'll be 90 over 27. All right, so I'm not going to solve it
Hold on
for
a
you.
minute.
No, you're good.
Wait a minute. You did EF.
Mm-hmm.
Wait.
EF to
EF
HF.
to. Hold on.
No.
EF. Where did my other color go? Wait. Oh, wait. Oh, there we go.
All right. So for these, you're just looking to find solve for x. That's literally all you're doing. All right. On the next,
So how'd you get the 90 over the 27 though?
so you have to do, because you've got EF over here, right? So I know E to F is 90, but that's on this top triangle. So I can put that
Okay.
on top. Like, see how this one's on top, that one's on top. Top triangles need to stay on top.
Okay, so order matters in this one too.
Order
so it can't
definitely
be flip-flopped.
matters. Right. Can't be flip-flopped. If you flip-flop them, you'll get awful numbers. Okay.
Will you like lose your mind if you flip-flop them? Like would I like freak out probably?
Yeah, you would freak out. Because instead of getting like a nice pretty number like 4, you would get like 93 over 19 and you'd be like,
She froze.
what is this? All right. So.
Wait, you froze. What'd you say?
Oh, sorry. I just said, like, if you flip-flop them, your answers would go from, instead of being 4 to, like, 233 over 9. And that's not...
Oh.
Yeah. Like, you would know, like, that
That's
ain't right.
not pretty.
No. It ain't pretty. We ain't doing it.
Okay.
All right.
Okay.
So, same thing for this one. We're going to highlight with... Where's my highlighter? I actually have highlighter. Highlighter. All right.
I'll be right back. I'm going to go get my highlighters.
Oh, you can just use regular pens. I'm just using the highlighter on mine because that's what I need. It just makes my life easier. All right. So PQ is my first 2. All right. See how it goes? First 2 here, first 2 here. I can match that with TS on my other triangle. So TS. All right, and then PR, which is way over here, matches with UT down here. And the reason it matches is because it's the first and last term, and then first and last term.
Okay, you're good. Keep going.
All right. So when I looked at this, I always go big over small just because that's how I consistently do it. So I'm going to do this as big, which is 7x plus 2 over the small part that matches it equals 35 over 14.
Can you solve this one?
Sure. So we're still
Thank you.
cross multiplying. So it's 14 times 7x plus 2. This is not one of those awful ones where you have to factor it.
Is the first one where you have to factor it?
No, first one you do not need to factor it.
Okay, hold on a minute. 14 and 7x plus 2 equals. Sorry, I have to say it out loud. Oh, you're good. 35 x plus 8. Okay.
All right. So for the last part, sorry, I have a coaster and it's got like this weird bubble on it. I couldn't tell if the paint was leaking off of it. And I was like, oh my God, that's bright blue. Like, let's not. All right. I'm going to leave number 3 for you guys because I want you guys to try it.
I thought you were talking about wanting gonna continue to set up the to solve the equation for number 2, but you're good. I know what to do after that. So.
Yeah. And I want to see if you guys are okay setting it up for this one. Remember,
Number
there
3?
is yeah, for number 3.
Okay.
For 2, yes.
Okay.
What'd she say?
She asked if the answer for number 2 was x equals 4, and I said yes.
Oh, okay. I haven't solved it yet, so I'll get there.
All right. So down here, we're getting to proving whether or not triangles are similar. So you've really only got 3 ways to prove that they're similar. You've got side, side, side. You've got angle, angle. And then you've got side, angle, side. Now, to actually say if triangles are congruent, then you have to check all of your ratios. All right. And I always go small
What are
to
those squiggly things?
that's the symbol for similarity.
Oh,
Okay.
okay.
It's kind of like the ish sign. All right.
Okay.
So for this one, go small to small. Go medium to medium. And then I would go large to large. And you just want to see if when you type them into the calculator that they all reduce down to the same thing. So 5 over 7.
21 to 15, and then 11.2 to 8.
Yep. Eight to 11.2, and then 15 to 21. All right.
8 over 11.2 equals 15 over 21. So then what are we supposed to do?
So what you're going to end up doing is you're going to type them into your calculator and see if they all reduce down to the same decimal. So it should be like point. It's going to be an awful decimal because it's over 7.
So for 5/7, should you get 0.7? Do you want us to round?
I just want, when you type it in on the calculator, like see down here where it says 0.714, blah, blah, blah.
You got to put it closer. I can see it. So wait, yeah, that's what I got. 0.714.
Yeah.
Blah.
So when you type in 8 divided by 11.2, You should get the exact same thing.
Okay, and then so
15 over 21, same.
One. So they're side.
Mm-hmm.
Okay. Do we have to do a congruent statement or whatever?
It says.
Please no.
No, let's screw it. Let's not.
Oh, okay.
Just call it side and be done. All right.
Okay.
Let's take that point from you.
Alrighty. Next page.
Are you just gonna save? Are we just gonna do 5 by ourselves?
Yeah.
Okay.
I'm
we do
actually
the
going to make you
even-
do a good chunk of these on your own because I did quite a bit of the last packet.
How'd you
Heaven
unplug
forbid
that?
you have like 15. You're going to be fine. All right. So on this one, I'm going to do 6, and then I'm going to jump down to the next section, which is Pythagorean theorem.
Yeah.
All right.
Okay.
So for
Okay.
6, if this one right here is 67, this angle right here also has to be 67, correct? Just based off of vertical angles.
If NP or angle P is
Yep.
67?
If this one right here is 67, the one on the other triangle has to be 67.
Okay.
All right. So then you got to figure out what's that missing angle on both of these. So for my blue triangle, I'm going to go 180 minus 67 minus 28.
Hold on a minute.
You're good.
180 minus 67 minus 28.
Mm-hmm.
You get 85.
All right. So for the other one, what's 180 minus 67 minus 82?
180 minus 67 minus 82. 31.
All right. See how you don't have the same 3 numbers between them?
Yes.
All right. So because you don't have the same numbers, like
Mhm.
it should be 67, 82, 31, period. But because the blue triangle is
Period.
off by the other 3 degrees, these are not similar. Okay.
Okay, hold on a minute.
I'm gonna take
So-
that point from her.
So, because wait, why are they not similar? What did you explain again? Like, what did you say?
So on that blue triangle, you know it's 28 and 67, right? So the only other option for angle N is going to be 85. Like it can't be anything else because it's already got 2 of those angles in there. Now for our little red triangle, I've got an 82 that I was given as well, but I can find this 67 using vertical angles, right?
Right.
So I need to solve for angle R down here and see if it's the same as this angle M up here. Problem is, because 82 and 85 aren't the same, R is not going to be the same as M.
Okay.
So you would have to have 3 pairs of congruent angles for this to work.
Okay. But you don't.
But I don't, so they're not similar.
Is it because it's 82 and not 28?
It's because it's 82 and not 85.
What?
So
Yep, I'm still lost.
just trust me on it.
Okay, I'm trusting you.
Okay. So the only way to do these is if you have the exact same numbers. If they're not all the same, you're done. All right.
Okay.
So I want to scroll down here to, this is that Pythagorean theorem converse that I actually hit in video 3. All right. So it's a squared plus b squared plus c squared, or not plus, my bad. Wrong symbol. All right, and that works if it's a right triangle.
Okay, so then why did you for where did it go? For the, hold on, I gotta find it.
Topic 2, I think, in review packet 3.
Yeah, why did you put the question mark in the line there and not equals?
So I'm going to show you why. All right. These are all Pythagorean theorem, just regular old Pythagorean theorem. Okay. What we hit in some of the problems was what kind of triangle is it? Okay. And it doesn't look like any of those are showing up on here. However, just because it doesn't show up in this review packet doesn't mean it's not going to show up later. So because it was so similar with what we were doing, I made sure I hit it earlier. But everything that you're doing on these, they're all Pythagorean theorem. So it's all a squared plus b squared equals c squared.
Okay.
Okay.
Can we go over number 15 and 16? Can we do number 15 and 16?
Yeah. And then I think we'll cut it there for today. All right.
Okay.
Because that'll be an hour video, and let's be honest, people aren't gonna watch a whole hour. All right, so I've got a baseball diamond.
My head's killing me, though. I'm getting too much math.
All right, so baseball diamond is a square where each of the bases are 90 feet apart.
Okay. Hold on.
We'll make this home.
$90, $90, $90, and $90. Okay, wait, where'd you put home? Wait.
I did home plate as being lower left-hand corner.
First. Second. Okay.
All right, so Andy is standing at first base. So here's Andy in his little stick figure glory. Okay, he's standing at first base, while his teammate Logan is standing somewhere between second and third. So here's Logan, who's standing way off in God knows where. All right, if the straight line distance from Andy to Logan is 98 feet, then you need to find the missing chunk, like how far away is Logan from second base. So what they're saying is this chunk right here is 98 feet. This is a right angle.
Hold on. This is 98 feet, and that's a right angle. Okay.
So what we really have in all of this complicated glory is a right triangle. And we'll go in here. All right. Where we know this part is 90 and this is 98. And we need to find this distance for Logan to get back to second base. So that's X.
Okay, so wait. 98, 90, and X. Okay.
So 98's got to be my hypotenuse, so that one's got to be C. And then it's just plug and chug. So it's 90 squared plus X squared equals 98 squared.
Okay, hold on a minute.
No worries.
Ah, shoot. Okay. Okay.
All right. Are you good from here solving for X?
Yeah.
Okay. This bad boy down here, I'm actually going to have you guys skip it because it's way too hard to go over on like doing this online. Like when I did this in class, like it still got confusing and I was moving pieces of paper around. If I try to explain it on this, y'all are going to lose your mind. So we're going to stop here. I'm going to make a separate video for special right triangles and I'll make a separate video for SOHCAHTOA and I will get those posted.